Hello everybody, this is a combinational circuit. That too, it is a 2 to 1 line multiplexer, quadruple 2 to 1 line multiplexer. So it is a mux circuit, but it is built using gates only. You know the gates. So here we have a number of inputs. See here in A we have 4 inputs and in B we have 4 inputs. Other than that we have these control inputs S and E. So here we have 2 inputs. So in total we have 10 inputs. Okay. So this circuit is being used in the question. Write the Boolean function for the 4 outputs in terms of the input variables. If the circuit is described in a truth table, how many rows and columns would there be in the table? So this is the question from 4.3 from 4th chapter of MORIS MANO's 5th edition. Okay, let's get started. So as I already told you, we have 10 inputs and this many number of, that is 3 number of NOT gates are used, and here we have 8 number of AND gates and 4 number of OR gates. Along with that we have this 4 number of outputs, and we are asked to give outputs in terms of this inputs as a Boolean function. Okay, so here this function table is also been noted. So here if you have this enable input E is equal to 1, so irrespective of this selection input, the output will be 0. Okay, so if you have this 0 value for this enable, then only the circuit gets activated. At that time, depending on the selection value, if it is 0, it selects A. If it is 1, it selects B. Okay, so this is the condition for the working of this multiplexer. So based on that, we can get this output as A0, A1, A2 or A3 on this Y0, Y1, Y2, Y3 output lines. So see here, first we'll get this first combination, that is 0 and 0 for this E and S. So E is 0, definitely the circuit is functioning or it is working. So S is 0 means what would happen? This is inverted, so here you have a 1. So that 1 would be applied through this line. So here you would be having 1, that is indicated by this blue. Okay. Similarly, at the same time, after once again it is inverted, the 0 will be applied to this line, to this AND gates. Okay. So this enable line, you are giving a 0, so it is inverted and it is taken as 1 and it is applied to all the gates. Okay, so whenever you get this E as 0, it supplies 1 to AND gates. So no need to worry about that. But another input, this one, right? This is 1 for this 4 ones, but it is here 0. So this AND gates are not supplying ones. It would produce only 0. So this A0 will be connected here and this A1 will be connected to this AND gate. Okay, so these 4 AND gates will be supplying the particular input A0, A1, A2, A3 to the corresponding output lines of this AND gate. So it is reflected in this OR gate also. Okay, so it is coming over here. So it receives this A0 along with the 0 from this particular AND gate. Again, this OR gate is receiving A1 from here and 0 from this or AND gate. And this OR gate is receiving A2, this OR gate is receiving A3. So that OR gate is supplying A0, A1, A2, A3. These OR gates will be giving the outputs as A0, A1, A2 and A3. So this is for the condition when S is equal to 0. So now we move on to the next condition. So when E is equal to 0 and S is equal to 1. So E is 0 means it is activated or enabled because it supplies a 1, and this is connected to all the input lines of these gates. So all these AND gates are receiving 1 corresponding to this enable input. But corresponding to this select input, it is being given 1. So this inverter supplies 0, so that is being connected here. Okay, it's 0 0 0 0. That means this is being deactivated. These all these first AND gates are deactivated, so it will give only 0 output. Okay, this is not given. A naught will not be reflected at the output of this first AND gate. Like that, A1 will not be reflected, A2 will not be reflected here. But what happens after one more inversion, it gets 1 here, and that one will be connected to this 4 AND gates. Okay, so based on these two ones, this particular AND gates are activated. So this B naught will be reflected at the output. So this AND gate produces B naught, this AND gate produces B1, this is producing B2, this is producing B3 at the output. So it is being connected here, right? Here you get B naught, here you get B1, here you get B2, B3, but other inputs are 0 0 0. Anyhow, it is an OR gate, right? So these OR gates will be supplying at the output Y naught as B naught, Y1 as B1, and Y2 as B2, and Y3 as B3. Okay, so it selects B. This selects A for the condition 0 0. Okay, so we got it. Now, how to write the output expression? So this output expression Y naught depends on this E dash, definitely, right? Again, this S dash, when it is 0, this A naught will be selected. When it is 1, this B naught will be selected, isn't it? So we have to write this. Similarly, this Y1 is the output, and it is depending on this E dash, that means 0 value for this E enable line. And when it is S dash, that means 0, A1 will be selected, and when it is 1, this B1 will be selected. So for Y2 it is E dash into S dash A2 plus S into B2. Y3 it is E dash into S dash A3 plus SB3. So now how many input lines we have? That is another question it is being asked, isn't it? So we have written the Boolean functions for the 4 outputs in terms of the input variables, and described in a truth table how many rows and columns would there be in the table. So we have 10 inputs. So what are the possibilities? How many combinations? It is 2 power 10, isn't it? 2 power inputs, number of inputs, 2 power 10. So that means it is 1024 rows we should have. And how many columns? So columns in the sense we have to represent the inputs as well as the outputs. So here we have 10 inputs. What are they? This A0 to A3 plus B0 to B3. So it is 4 plus 4. Already I have told you. Plus this enable plus this yes, isn't it? So it is 1 1 2. So we have total 10 inputs. So that must be mentioned in the column. This corresponds to column, right? So 10 inputs plus, then we bother about the outputs, isn't it? So what are the outputs? Number of rows 1024, that is based on 2 power 10 number of inputs, and the columns that depends on inputs plus output, isn't it? So 10 inputs plus 4 outputs. That's why we require 14 columns. Okay, so this is the answer. Thank you.